Determine the reference angle for the following given angles. So I can see in part A, I have 893 degrees. And so this angle is not seen in kind of the first positive full rotation in, let's say, like the unit circle. So in this case, I'm going to need to kind of think about it, think about where it is, spend a little more time doing that. So I'll still draw the initial side on the positive x-axis. And now I want to think about, okay, well, like how many times do I go around and all that? So I know that one time around is 360 degrees. So if I just draw one time around, let's see how much I have left. Well, I like to think of that as 893 degrees minus 360 degrees. So if I do that, I'll just go over to my trusty calculator, 893 minus 360. So I get 533. So since 533 degrees is still more than 360 degrees of full rotation, I'm just going to draw in another full rotation there. So now I've done two full rotations. So now I'll take 533 degrees and I'm going to subtract 360 degrees. So let's see what I get there. All right, so I'm just subtracting 360 from my answer before. I get 173. So I get 173 degrees. Okay, so 173 degrees, what I note here is this is just 7 degrees short of a half rotation. Okay, so I'm going to take where I left off and go almost all the way around, but stop just short of it. Okay. So then I'm going to draw my terminal side there. That's about right. And I'll label this angle. This whole thing is 893 degrees. Okay, great. So now I want to find that reference angle. So to find the reference angle, first identify the terminal side of that given angle, right? And so its reference angle will have its terminal side either on the positive x-axis or the negative, and it's whichever ray will make the smallest angle. So I can see, or just the smallest opening, think of it that way. So I can see that that negative x-axis is going to do that. So I go ahead and draw that in there, okay? And again, we can like label this, say like T prime is, you know, what we're calling it from the definition. But what we usually care most about is how big it is. So sometimes you can just see that, you know, just from the picture. But if we want to make an equation to solve for it, sometimes we need to do that when it's a little trickier. I can do that. I can see that T prime plus that 173 degrees, which was that last kind of movement that we went, that whole thing is half a rotation, so it's 180 degrees. So T prime will just be 7 degrees. And that is the size of the reference angle. Okay, great. Let's do another one. So here I say, determine the reference angle for negative 17 pi over 5. So in order to do that, I need to know where does negative 17 pi over 5 live. Well, I know its initial side will be on the positive x-axis, and I have to start heading clockwise since it's negative. And then I probably want to think a little bit about this. Like, I know that, you know, this is 0, but if I'm going to start thinking about the rotations around, I would say, okay, well then this would be negative 5 pi over 5, right? Because that's the same as negative pi. And that means if I started at that initial side and made it halfway around, but again, going that other direction, I'd make it to negative. Okay, so let's do that some more. Then if I made it all the way around, I'd be at negative 10 pi over 5. Again, negative because of the way I'm going. Does that get me at my angle yet? No, that's negative 17 pi over 5. So I can see I'm just going by 5 pi over 5, which is just pi, where it's going to alternate. So I would also write this as negative 15 pi over 5. All right, now I'm getting closer. So like, what have I done so far? I've gone all the way around in the negative direction and then another half rotation to be at that negative horizontal axis. And now I just have, if I've done 15 pi over 5 of the move, then I just have 2 pi over 5 of the move left. So what quadrant would that be in? Well, one way to think about it is like this would be negative 20 pi over 5 on the positive x-axis if I did 2 full rotations. So what would be in between? Negative 17.5 pi over 5. Okay, so that's kind of a funny looking angle, but it just helps us to think about like what would be in between. And so since I have negative 17 pi over 5, it's going to be in the spot that is between negative 15 pi over 5 and negative 17.5 pi over 5. So again, that's going to put that here in quadrant 2. And again, it might not be perfect, but we'll put it like the terminal side in quadrant 2. And then I'll label this angle as negative 17 pi over 5. Okay, so what was I doing? Well, I need to find my reference angle. So for my reference angle, I know I start with the terminal side of that given angle, and then its reference angle will use one of the sides of the x-axis or horizontal axis as its terminal side, or in this case, we're not really doing initial and terminal because we're not in standard position, so we can just think of it as the other ray. So which one am I going to choose? It's whatever makes the smallest opening. So in this case, it will be that negative horizontal axis again. So here's that. So I've actually found the reference angle. I can point to it now. And then the second piece to that is going to be identifying how big it is. So what is that? Well, I know that negative 17 pi over 5 is where I put my terminal side. And negative 15 pi over 5 was kind of the marker for, right? So like this part here is all the way to negative 17 pi over 5. And then this was negative 15 pi over 5. So I'm really close about how big of an opening it is. And again, reference angles are always positive, right? They're acute angles, meaning between 0 and 90 degrees. So in this case, it's just going to be 2 pi over 5. All right. So now let's determine the reference angles for these following angles. And so I have 0.7, 2.1, 3.8, and 5.4. So these are in radians, but it's not in a multiple of pi. So it just makes it a little bit trickier. But what we can do is kind of think about how we would label, like how far are we in radians in each quadrant. So we know that we start it with 0 radians, and halfway around is pi radians, but we can put that in our calculator if we want to. So we know that pi is equal to 3.14. I would say just 3.1 is fine for what we're doing, because we're just trying to get like which quadrant are each of our angles in, right? That's what we care about. And so we need kind of to think about, well, how big are the quadrantal angles? So let's check out the 90 degrees. That would be pi over 2. Pi over 2, I get 1.6 about, so about 1.6, okay? And then down here, if I want a 3 pi over 2, right, I just put my 3 up there, 4.7 about, so about 4.7. So that should help us to think about where these live. So let's put in 0.7. Again, that's just my regular kind of given angle. And for all of these, I'm being asked to find the reference angle. So 0.7, I'm going to draw in quadrant 1. If 90 degrees is 1.6 radians, right, I'm about a little less than half of that. So this is my 0.7. And again, that's in radians. If I don't have that degree symbol there, I can assume that. Okay, so what would my reference angle be? Again, I just have to draw it every time. So terminal side, I'm going to mark that as one of the rays. And then the other ray is going to be the closest part of the x-axis. That's this direction. So in this case, I can see that the reference angle is just the angle itself. So they have the same size. So the reference angle is 0.7. Okay. All right, let's do the next one, 2.1. Well, 2.1 radians is larger than 1.6 radians, but not as many as 3.1 radians. So I need to draw its terminal side in quadrant 2. The initial side is just on that positive x-axis where we would expect it. So here's 2.1 radians. And what about its reference angle? So reference angle uses the terminal side of 2.1 radians as one ray, and then the closest part of the x-axis for the other ray. In this case, it'll be the negative part of the x-axis. So this is the reference angle. And again, if we need to give it a name for some reason, we can call it T prime or something like that. And we want to know its size. Well, this is where I want to make some type of equation where I have 2 parts equals a whole. So what I see here is that T prime plus 2.1 is equal to, well, what's halfway around, right? What would the measurement be if I just went like that? Because that would be both of them together. Well, that's just pi. And in this case, I want to, in this case, I do want to be exact. So 2.1 we can assume is an exact number. Let me find my way back up. We're getting a little preview here. 2.1 is an exact number, so we'll do 2.1 t prime is pi exactly. We use the approximates over here just to find out like what quadrant approximately where each of these angles would live, but we want to keep it exact when we do our calculations unless it asks for something else. So t prime is pi minus 2.1, and that's the reference angle for, here's my reference angle for 2.1. Okay, let's try 3.8. So just based on what I did before, I can see that 3.8 will live in quadrant 3. So that's its terminal side and initial side on the positive x-axis. This is 3.8, okay? And we want to know where the reference angle is. So again, I'm going to draw, kind of highlight over that terminal side of 3.8 radians. And then I can see that the negative x-axis will be the closest piece of the horizontal axis for me. And then I can just go ahead and draw that in terms of label it. So that will be my reference angle, I'm calling it t prime. And then how can I find out its value? Well, they are going to be, think of it as like 3.8 is all the way. So think of that as the whole. So I have something plus something is 3.8. That's the biggest angle here. T prime will be part of that. And then the other part, right, if T prime shares the terminal side here, but then it ends. And then to get all the way back to that positive x-axis, right, so I've kind of gone this amount. If I want to get all the way back here, that's just a pi rotation. So t prime plus pi is 3.8. So t prime will be 3.8 minus pi. So this is the size of the reference angle for 3.8 radians. All right, almost there. So let's do 5.4. So based on our calculations before, 5.4 is going to be in quadrant 4 in terms of its terminal side. So that's kind of what we care about since all the initial sides are on the positive x-axis. So 4.7, 5.4, 4.7 is all the way down. So 5.4, maybe something like this. Okay, so this is 5.4 is this angle that I've drawn in. And then what would its reference angle be? First I'll highlight that terminal side, and then the closest part of the x-axis is going to be the positive x-axis. Okay, so this part of the opening is going to be the reference angle. It's a little confusing because it kind of looks like the same angle, but one is saying start at that initial side, right? Like start here and rotate that all the way around and then land here. So that's like how big the opening is, right? It goes all the way past that. Whereas here, we're just talking about this like little mini opening here. So how do we measure that? Well, we can think of it just as we've done with these other ones. We say, well, 5.4, that angle, plus its reference angle. So I think be consistent here and call it t prime, right? If we add both of those together, meaning we start at the beginning of 5.4 and go around, and then keep going, we cover that reference angle, right? Those added together make a full rotation, which is 2 pi. So t prime will be 2 pi minus 5.4. And so this is the reference angle for 5.4 radians.